In lesson 5.2, we continue on with the idea of angles in a polygon, but this time, instead of concentrating on the inside angles in a polygon, we're going to concentrate on the outside angles. So we already knew that the interior angles of a triangle were 180. And in this example, we look at the exterior angles, which when we extend out the sides of the triangle, what we notice is that the 85-degree angle on the top has a supplement of 95, the 30-degree angle on the right has a supplement of 150, and the 65-degree angle on the left has a supplement of 115. If we take these three angles and we add them up, that is, if we take the 95-degree angle, the 115-degree angle, and the 150-degree angle, and we total those up, we see that we get a grand total of 360 degrees on the outside of this triangle. That's the sum of the exterior angles of the triangle, whereas the 180 we learned last time was the sum of the interior angles of that triangle. Let's continue on with this idea. Let's look at a quadrilateral or a four-sided figure. Again, we could look at the inside angles, 90, 90, 90, and 90 if this happens to be a rectangle, which means that my exterior are also 90, 90, 90, and 90. Or in other words, if I total up those four 90s together, I see a grand total of 360 degrees for the sum of the exterior angles, even though we knew on the inside we had the interior angles summing 360. So in the blue, the sum of the exterior angles for a quadrilateral were 360. The same as we learned previously for a triangle. Let's go a step farther. Here we have a pentagon. In this pentagon, if we look at the inside angles, and if it's a regular polygon, we would see that the five interior angles would be a grand total of 108 each, for a grand sum of 540 degrees, which we see down below and we learned earlier in the previous lesson. But if I then look at the exterior angles of 72 each, and I total up all of those, this was a 72 over here, what I would see is 72 5 times. And if I add up all those, I get a grand total of 360 degrees one more time. I can do this one more time, just like we covered all the way through hexagons last time, and I see that the interior angles of this hexagon, that means the inside, are each 120, for a grand total sum of 720 degrees inside of a hexagon, which we learned in lesson 5.1 again. This means as I extend each of the sides and I look at the exterior angles, each would be 60. And if I add up all of those angles, what I notice is when I have the five angles times 60 degrees each, six angles, of 60 degrees each, I get 360 degrees. Interestingly enough, we learn again that the exterior angles are 360 degrees. What's the moral of this story? The moral of this story is that no matter what, we will always have the sum of the exterior angles being 360. What's nice about that is then that means that you can always find the interior angle, because all you have to do every single time is take 360 degrees and divide by the number of sides, and that will give you the exterior angle. And then if you want to find the interior angle, what you would do is you would take 180 minus that amount, and that would give you the interior angle. Let me show you an example. Let's say down below that I am talking about the pentagon. In the pentagon, I know that I have 5 sides. So if I take 360 degrees, which is the grand total of how many degrees are in the exterior, and I divide this by 5 sides, and I look at just the exterior angle, which is right here, the exterior angle in the orange, then 360 divided by 5 gives me a grand total of 72 degrees. That is representing the the pink circle. So I know the exterior angle is 72 degrees. If I then want to find the interior angle, or the one that you see in brown, the one right here next to it, in order to find that brown angle, what I will do is I'll take 180 degrees for a straight line minus the 72 degrees for the exterior angle, and that would give me a grand total of 108 degrees for this interior angle. So what I like to do is whenever I'm trying to find an interior angle, if I don't know it, I take the exterior angle by taking 360 divided by the number of sides, and then to find the interior, I subtract that number from 180 degrees. Again, the moral of the story is that we know that the sum of the exterior angles of any polygon, any of them, will always be 360 degrees. So we can use that knowledge to find both the exterior angle by dividing by the number of sides, and then also the interior angle by subtracting whatever the result is from 180 degrees.